My name is Samantha, and welcome to your first hands-on embedded system workshop. Today, you'll be building your first circuit with blinking LEDs. You can find schematics, the slides, and coding resources in the description below. Let's get started.
And we can go ahead and start with our kind of first hands-on workshop. So today is blinking LEDs for our embedded system workshop. And basically a quick overview for the project. The purpose for this is kind of just doing a basic intro to circuits and kind of knowing how all the elements work in a circuit and proper design and structure. And we'll also be using the Arduino IDE. So that's basically where you can put your code and kind of connect that to your circuit and have it be interactive with the LEDs and learn how to send the digital outputs using the Arduino IDE. And we'll first start off with just one LED, which are those like lights, little lights, and then we'll go on to multiple LEDs. So we'll have a circuit, and we'll need the kit for today. And if you don't have your kit, you can let us know, or if you have any problems with getting it, also definitely let us know. But yeah, hopefully you guys have your kit with you for the Arduino. And for this project, we'll need the controller board, USB cable, so you can connect the board to your computer and your breadboard, the LEDs, resistors, and the jumper wires, the male jumper wires. And I believe there's like pictures and labels of all the parts in the kit. And before we start, kind of what Arduino is, because you may probably haven't ever used this or kind of seen Arduino before. And Arduino is just a microcontroller, and you can use it for a lot of different things, like whether it be doing the LEDs, like the light bulbs, or sensors, a bunch of different cool things. And you program Arduino using C and C++. So because it's open source, there are many Arduino compatible and derived boards that exist. And here's some pictures of the Arduino boards and all those wires you see there. And C++ is what we use to code Arduino in the IDE. So C++ is just a language we use for embedded systems and applications and operating systems and all sorts of things that you probably use every day. And you have to compile your code before it executes, so that's one sort of unique thing about it. And it's open source, so we'll be using some basic C++ kind of just to get Arduino working. And I think, Stefan, I think will talk about the design for it.
All right. So getting into basic circuit design. So a circuit is called a circuit because it forms a loop. And this is a loop that electricity can flow to. Electricity is always going to flow from a higher voltage point to a lower voltage point. All elements in a circuit will fall into one of three general categories. though as you get more advanced circuit design, this may change. There may be more types of elements. First one is voltage source, and this provides the power to a circuit. You may have seen, say, 9-volt batteries or whatnot. Those are voltage sources. And Arduino has 2 voltage sources. One is 5 volts and one is 3.3 volts. And any of the pins can be set to, I believe, 3.3 volts using the code. The next element is called ground, which is simply the lowest voltage point in a circuit. And all circuits should be designed that they end at a ground pin. And then lastly, we have loads. A load is simply anything that causes resistance in a circuit, such as, well, resistors, LEDs, motors, screens, what have you, that requires electricity. With circuit design, there's a couple of safety hazards that I want to go over just so nobody fries an Arduino, blows an LED, you name it. First one is simply too much current. If you ever heard there's a saying in electrical engineering, it says it's not the voltage that kills you, it's the current. If you have too high of a current, which may be due to not enough load on a circuit, such as not enough resistors, or for example, too much current can damage parts in a circuit. For example, you can blow an LED, you can spin a motor until it breaks itself, or you can damage the Arduino itself. And by the way, this is why circuit breakers exist. If there's a surge in current, it will break the circuit, prevent that surge electricity from damaging the electrical components of your house. Next up is a short circuit. This can happen on accident, usually. It happens when electrical current can take a much lower resistance path than what you intend, and then it can cause a lot higher currents that, once again, can damage parts of the circuit. If you want to make sure a short circuit doesn't happen, make sure all your wires are connected to what you intend to connect them to. Make sure check all of your wires before powering the circuit on. And this is something important. Don't change the wires while the circuit is powered on. You could probably cause a short circuit doing that. So here's a basic circuit for a blinking LED. We have the Arduino, breadboard, resistor, LED, and a pair of jumper wires. So the first jumper wire goes into the Arduino pin 7 into the breadboard, and then that jumper wire feeds into a resistor to slow down the current and not blow the LED. Then it goes into the positive pin of the LED, and then which then flows into another jumper wire through the rail on the breadboard. And then the second jumper wire, which is the black one in this instance, goes to our ground pin. So this is a complete circuit. The pin 7 here is what would be providing the power. And I believe this is where we would start assembling a circuit like this. Yes.
Yes, so if you have your kit, take it out. You might want to go back to the diagram for a sec, give them some time.
Yeah.
I can also post a copy of the slides so they can look at it.
Give you some time to assemble a circuit like this. Okay. So Sam, you wanted me to explain some of these components to them?
Yeah, I think there's another slide with a diagram after like breadboards, LEDs, and resistor slide. So we can talk about the parts first, and then we can go into building a little bit.
There should be a breadboard in there in that kit. if you open up the
Is this the breadboard or is this the breadboard?
hold on, which one is it? Let me see. One of those is the Arduino. The second one is not a breadboard. The breadboard, I think, will be in a box that you have to open. I mean, a small cardboard box, I think.
Yeah, it's in it's in this box.
Yeah, it's just a big. The one you get in the box is bigger than the one shown in the picture, but it's functionally the same. Yeah, it'll be at the bottom of it'll be under probably a jumble of wires in the kit.
Is it this thingy?
That's the one. Just open that box. Be aware that it might be a little bit sticky to get out. My sister and I had that problem when we were opening it. Be aware that it might be a bit hesitant to come out. Or it may just slide out no problem like that.
Is this the Arduino? Or the...
That's not the Arduino, no.
Oh, okay.
The Arduino, I think, will have Arduino labeled on it. Or at least something like Uno labeled on it.
Wait, is this the Arduino? This thingy?
That I think is the Arduino. If you could take it out of the package, I'll let you. If you can take it out of the package, I can get a clearer view for you. That is not the Arduino there yet. That's an Arduino. That's an Arduino camera. One moment, be right back.
How exactly would you stick in the LED line?
All right, I'm back. Sam, you gave me a kit that still has the buttons attached to it. Okay.
Oh.
Should I just take this whole button circuit apart then?
Yeah, you can take it apart. The schematic is ready for next week, so we should be able to replicate it.
All right. Out you go. Out, 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 out. All right. Just rearrange a couple of things, and there we go. All right. That's said and done. Where did I put there's the buttons bag? Oh. Oh. Let me get this guy prepped first. There we go. Okay. All right, I got the kit now. All right, sister, here's what you wanted, right? Cool. All right, everybody managed to get their circuit set up or no? Not yet.
Can you hold up your model again?
This one has two LED. This one has two lights on it, but it should function more or less the same. Just this one has a second light on it. You can also just take a look at the schematic we currently have on the screen. Oh yeah, the zip tie. Just use a pair of scissors and cut the zip tie.
Do we peel off this yellow backing for the backboard?
No, the breadboard, no, not unless you intend to permanently attach it to something, which right now you probably don't.
How would she stick in the LED light?
So the LED has two legs. The longer leg will go. So hold on. Okay, so the circuit should look something like what we have on the screen, right? The longer leg will go into the one that's connected to the resistor. It will be connected to the same row as the resistors, and the shorter leg will go into the one that. Hold on. And the shorter leg will be connected to the rail the rail that goes to the ground. In this case, I don't mean the literal ground, I mean the electrical ground. Okay.
Oh yeah, I think this slide is a lot better to like actually see how it kind of looks.
Yeah. So each LED will have two pins. One's called, let me pull up one of these LEDs. Here it is. All right. So each LED here, like this one, will have two legs. The longer leg is our anode. You can see in this one here. The shorter leg is our cathode. The anode is your positive pin. You want that to be connected to whatever your power is. In this case, the power is any one of these pins. The shorter leg is basically your output, and you want that to be connected to wherever the ground rail is. I think this would be also a good time to explain these rails on the breadboards.
Wait, are these things the resistors?
Yeah, that's a belt of resistors right there. You wanna go cover? You wanna take a look at the resistors? All right. Okay, so here's what resistors are. A resistor is simply something that slows down the electric current, and you use them to control how fast the current flows. Resistance value is measured in ohms, and the resistor's resistance is represented by a set of colored stripes on this body. And each stripe has a different value depending on the color and the location is in the reference chart. For example, on this 4-band resistor, this 4-band resistor, we have a yellow, which represents 4, a purple, which represents 7, green. This orange represents 1,000, so times 1,000. And then we have a tolerance, which is plus minus 5%. So this one here is 47,000 ohms. Oh, you can't get the zip tie to come off with the O. I think what might help to get it off is to try cut, like untwist it. Huh. That works too, I guess. We'll cover probably in later lessons is a potentiometer, which is simply a resistor that you can control the resistance of on the fly.
Where do you attach the resistor?
So the resistor can realistically go anywhere. Actually, Sarah, would you mind going back to the slide that shows the LEDs? Sarah? There we go. So in this example, we have our power pin going into this red rail here. I should probably take a little bit of time to explain the rails on the breadboards. What do you think? So I should probably explain something about the breadboard. So on this breadboard, we have 2 rails on either side that go the entire length of the breadboard. We have all these pins here and go along here. These side rails here, they go the entire length of the breadboard. For example, if I connect an LED to this one here, and I connect this LED here, anything, it will be electrically connected to anything that's along this rail here. So I've connected it into this blue rail here essentially, and then it'll be connected to everything on this blue rail. Same goes for the red rail, it'll be connected to everything on the red rail, and then same for the other 2 sides. In the middle of the breadboard, if I connect the LED here, so we have little groups of 5, we have a bunch of rows of 5 pins on the width. If I connect this LED here into this pin here, it'll be connected to any of these pins here on the bottom, but not the ones here, So basically it'll be connected to everything on here. So it's electrically connected to these 4 here, but it does not cross the middle. Basically what you're intended to do is have your power source along these side rails and then have all your circuitry in these middle little rails. Somebody asked, where does the resistor go? And there's one of 2 ways you can do it. You can connect power to LED, then LED to resistor, and then resistor to ground. Or you can do power to resistor, resistor to LED, LED to ground. Either way works.
How do you connect the resistor to the LED light? Or do you not at all?
You don't connect it directly. You connect it through the breadboard rails.
Okay, and how do you get this thingy off?
That.
I can't seem to get it off. I tried cutting it off.
You gotta use a lot of force to cut that. You need a lot of force to cut that thing open. Try not to break any of the wires. Yeah. Yeah, follow Samantha's tip there. Yes, if anybody has any questions about how to set up the circuit, now's the time to ask.
Yeah, to connect the Arduino with the breadboard, which string do you use to connect? Because there are like 2 patch of them, and
You mean the jumper wires?
yeah, like you connect them with the breadboard with to
Right.
Arduino.
All right. So the jumper wires you find doesn't really matter which ones you use, as long as they both have this as long as they both have this little metal end here. As long as,
Can you raise like a little so I can see it?
yeah, so the jumper wires you use, for example, I have this white one here. As long as both ends of it have this little metal tip here, then that's the one you should be using. You can use them any color, any length that's long enough, any color. So it's generally good practice to make the black ones be for where you're connecting to ground, and the red ones would be what you're connecting from the power. I should probably also mention that I believe in this kit there another kind of jumper wire. Yeah, there's another kind of jumper wire. This one has an end. Let me turn this guy off here. So we have another kind of jumper wire which is similar. Oh yeah. So there's 3 different types of jumper wires. And it depends on what kind of ends they have. So this one, so the jumper wire has 2 ends. In this example, we have what's called the male end. This one here is what we call a female end. The 3 types of jumper wires here are, this one is a male to male, which has 2 male ends. This one is a male to female, which has 2 female ends. And then there's the female to female, which has 2 female ends. I don't have an example of here. How it works basically is the male end plugs into a female end. We'll actually show it with 2 different wires here. So a male end will plug into a female end. And the breadboard is all female ends, by the way. And the pins on the Arduino are also all female ends. So you need male ends to plug into those. As to why the ends are called male and female, I don't know actually. I actually don't know how they got the name. Oh, the zip tie? You can't cut that thing off? Uh-oh. That thing is hard to cut off, yeah. You can try and wedge one side of the scissors in and then cut it like that. You might be able to see some results. You can wedge one half of the scissors under the zip tie and then cut it.
Connect the wire. Do you connect them with the 5V and the 3.3V?
Oh, so I got the light working. You only connect one. In this case you can connect it to the 5 volt. 5 volt connect to the breadboard. So the actual ports, it does matter to an extent. You can place them on any row. It doesn't really matter what row you place them on, but it has to follow a certain pattern, basically. So jumper wires, I'm going to pull up my circuit as an example here. So as an example here, I have this pin here, which is my power pin. That connects into here. No, you're not going to be using every single wire, but it's helpful to have extras just in case you accidentally cut one in half, for instance. Oh. Yeah, if you cut 1 or 2, it's probably not going to make a difference. Anyways, so run it to answer your question. So, for example, this wire here I have connected to one of these pins here. You can connect it to the 5 volt for this example, and then I have that connected to the breadboard here. Then from this wire along this horizontal plane here, along this horizontal rail here, I have a resistor here that goes into this side here. Remember, because the electric current won't cross the middle here. And I have that go into the positive pin of the LED. Remember, the LED is directional. The positive pin, by the way, is the longer pin of the two. Then the negative pin of the LED, which is the shorter leg, connects to this rail. And then I have this rail here connected to my ground pin through another wire, which I can probably just simplify this. And connect that straight to ground, like so. Like so. I have the same thing on this side here, just with a different pin as the input. That's the right thing. And by the way, one thing to note, the resistors, it doesn't matter which direction you put them in. Certain elements, it does matter. With resistors, it does not. Why you're not fitting into the breadboard? Yeah, sometimes it's a bit stubborn to. It'll take a bit of time to go in. It's stubborn to just go in there. Try connecting it to a different rail. Try using a different rail if it takes a while to go in, because a new breadboard tends to not want the wires and whatnot tends to not want to go in sometimes. Okay. Voltage bend. Should we use another one? You can try and unbend the tips, but I'd just say use a different one. Resistors seem to be particularly prone to having tips bend. Oh, oh no. That's not good. Kenna, you're muted, by the way, if you want to say something. Okay. Just try and wedge the scissors in there. I don't think cutting any more wire is going to solve anything at this point.
Kiana, try doing just one edge of the scissor.
Just wedge one edge of the scissor in there and then just cut that down. Okay,
Oh, she got it.
Cool. All right. Let me see your circuit then, Kiana. Oh. Oh, one thing I should mention first, you have the circuit set up and light bulb isn't shining. You probably don't have the Arduino plugged in. You should have the Arduino plugged into a USB port, which I'm sure you will have plenty of. Huh. You can
Oh, is it plugged into like your computer
It's
USB?
plugged into a computer USB port. So you have this wire here. One end will go into here will go into the Arduino. This other end will go into a USB port, which is out of view for you guys. And oh crap! Okay, but I have a mug in the way. I need to move this mug out of the way. Just slide this guy over. Oops, slide that a bit too far. I'm going to connect one of these straight to the 5 volt just for demo. 5 volt. And then if I plug this into the USB, there we go. I have a light shining because now my Arduino is powered. Oh crap. I don't have the other one shining because I did not connect that directly to a 5 volt. I'm just doing this one for demonstration purposes.
Where do you connect this end to?
That end, there's a port on the Arduino. It's a little rectangle, it's a metal box of sorts that'll plug into
Wait, which one? There's two different ones.
Show me your Arduino real quick.
There's one right here. This one, and there's one right here.
There's one. It'll be the metal-looking box. You'll be able to
Wait,
plug
is it
it
next to the super long bar, or is it next to the little port things?
It's connected to. It's right next. So you see this bar here. So the plug goes in here. This metal-looking one. This shiny-looking one here. And then the other end goes into a USB port on, say, your computer. And assuming you set your circuit up right, yeah. And assuming you set up your circuit right, you'll have a blinking. You'll have a nice shining LED. Mine is unusually bright, probably because I think the resistor here is this resistor is probably on the low side of safe, but it still should be safe. know, Sam, I actually kind of want to.
Should the orange thing be flashing? Because mine is.
The orange light on the Arduino.
Yeah, it's flashing. I don't know if it's supposed to do that.
Hold on. Let's see. What is that? Let me see.
That
Hold
should
on.
be okay.
It should be fine, yeah.
And then the light doesn't light up.
Let me see your circuit then.
How am I supposed to?
Okay, hold on. Well, it's blurred out for me. Let me put Do you have like back? Yeah.
Better?
Let me see. Oh, there's the issue. You gotta. I think you have a short circuit in there. That's what the flashing light is.
Wait, I have a what
I
circuit?
think you have a short circuit because you connected. So you have the power going into one of the red rail, I believe, and then you also have the ground connected to the red rail.
What?
Let me see. Show me your circuit one more time.
Okay. Uh-oh. I don't know if it's because the wires or something.
Yeah, it's because of the wires. You connected both the wires that go into the 5-volt and the wire that goes into the ground. You connected them both into the same rail.
So now I put them into separate ones?
Move the one that's ground into the one that's blue, like with a blue line beside it, and then make sure the one for power is either into a red rail or into the resistor. Or into something.
Wait, what?
So let me show you my circuit here. Let me show you my circuit. So the way I have it set up, this is just simple here. The way I have it set up is I have, so this one here is 5 volts. This one here is my 5-volt jumper wire. That goes into this rail here, just for simplicity. And it goes into one of these rails that goes across the width here. I mentioned before that on a breadboard, so these rails here along the sides, they connect to everything along the entire length. So they don't connect to each other. For example, the one with the blue on the side connects to everything along here. The one on the red connects to the one that's. I think I have a pencil here. I can use that. Just put it better. Yeah, here. So with the breadboard, you see this rail with a blue line beside it. Whatever you connect here on this here will be connected to everything along here. Electrically connected. And then the one on the red here will be connected to everything along that. And then on the ones here that are in the middle here, say we're connected in here, it would be connected to everything across the width here, but it would not go across the center. So if I were to plug a light into here, it will be connected to these other 4. So what you ended up doing is you connected both the one for power and the one for ground into the same rail, and that causes a short circuit. Luckily, the Arduino does have short circuit protection, but just keep that in mind. Does everyone else have their circuit set up, by the way? Sam, do you think we're good to move on to the actual coding part, or no? Or not yet?
I think we're good to move on. I think,
Okay.
oh no. We can introduce the code environment so people can get started on that,
Yeah.
and then while that's happening, we can try and get Keanu and Ronit's Arduino sorted out. We can introduce the coding stuff.
And oh yeah, I think it should be able to like light up without having to press the button if it looks around the same placement as the slide here. If it's like almost exactly like this, then it should be able to light up. But yeah, I think we'll do some of the code and then we can definitely help with that. Oh, and make sure your wires, one wire goes into the GND port and then one's in the 5V. But yeah, we'll do some of the code now. And here is, if you don't have the IDE downloaded, that's the link if you don't have that. I think there's also a website or like an online editor, but I think you need an account for that. But you can choose either way, whichever one's easier. And once you have the IDE downloaded, you can start putting some code in, and that way you can control your LED and have it blink or do different things you want it to. So I think downloading it, if you haven't already, it takes a little bit, but if you do have it downloaded, you just need to follow a few of these steps. So once you have it open, you want to click on File, which should be in the top left corner, and that way you'll be able to save this board here.
Yeah.
And save it as blinking LED, so you will be able to differentiate all your different files or codes. And if you haven't done so, definitely connect your USB cord from your Arduino to your computer. And if you want to check if your board is recognized, you can open the Tools menu. And that way you can check if the COM3 is there, or the name of your board. So this is kind of just checking that everything's connected. And yeah, the other option is the online web editor, which you just need to create an account if you don't want to download Arduino. And for the online web editor, you just need to click the Getting Started button and scroll down to see the Arduino plugin setup. And that way you'll be able to just not have to download an app and you can just use the website. But the application is nice, so you don't really need to have a login or have an account. And whichever one you have, whether it's the web editor or the app, you'll be able to program your Arduino. And this is for the web editor. If you are using that, you want to sign in with Google, so you can use your personal email, not your school email. And once you have saved your board, you can create a new sketch, which should be a button you see. And I want to rename it digital input. So you probably have the cord, your USB cord already connected to your computer, and you want to check if your Arduino has been recognized by just checking the, I think it's like top left area. And here, if you've seen this image down here, there shouldn't be like an X next to the Arduino Uno. And it should just look like the bottom one here. And this is just for the web editor, not for the application if you downloaded it. But let us know if you did have any problems with the IDE. Yeah, I can go back. And if you ever need to read any of the instructions, I think, oh yes, Sam sent a link to the slides. But I'm gonna quickly go back. Oh yeah, so if you have the application, this is the instructions to save it. So that way you'll just be able to know which board and have it be recognized. And naming it will help you kind of organize everything. So blinking LED. But yeah, if you have any kind of issues or troubles with this, definitely let us know.
Where does it say new sketch?
Oh, this is for the if you're using the web editor, but if you have the Arduino downloaded as the application, then it won't have the new sketch button. And
I'm on the web editor though.
oh, the web editor.
I see like what is the
Let's see.
never mind.
Oh yeah, that's okay. Yeah, that's good. Oh, your port isn't being recognized. I think. Yeah, I think that issue does happen sometimes. I'm not too sure. And oh yeah, for the orange light, it should be fine if it's flashing. So yeah, don't worry about that. But for the port not being recognized, I think
What is the port called? Like on the slide, it doesn't show all of the words. What is the port called? It says select board or port, and then am I supposed to like type it in or something?
I think it should be like Arduino Uno.
Something like Arduino, yeah.
Is it a programming port or just
Programming, I don't think it is.
wait? Okay.
I think that might be the one. Yeah.
Yeah, try that and see if that works. I think it should.
It doesn't find that.
Huh. Huh.
Bye, Sarah.
Adios, friends. Have an awesome weekend.
Okay.
Yes, you too. Oh, that's good. The port's showing for you now. Oh yeah, it is 5. I think we probably can't get to the blinking, but we'll try and get more of the...
I got the red light to turn on, but then I can't find the port. So should I just work on it next week?
Stefan, do you know if you're available next week?
I will get back to you on that.
Okay.
I can't find it. Like in the slide, it has a picture of the name and stuff, but it doesn't finish it. It's like cut off. So I have no idea.
Hold on. Because if you're available next week, we've kind of made it an office hours, so we should be able to finish the lesson if people want to. I think building the circuit will take the most amount of time.
Yeah.
It's cut off, but it should say COM 3, COM 9 or something. It depends on your port, but it'll say something.
Okay then. I guess.
Oh yeah, we can help with that.
Yeah, I'll do it next week, I guess, because I can't find it. I've tried every single one, but it doesn't. Is there a specific name it's called or something?
I think Arduino Uno